determine and fully simplify the difference quotient. So the difference quotient, the definition, and I have to write it, it's f of x plus h minus f of x divided by h. This has to be in your memory, extended memory notebook, let's call it. You have to write what it is. It's the rate of change of the function between 2 points. One point with p x comma f of x, and the other point p q x plus h comma f of x plus h. The rate of change between 2 points. Very good. The average rate of change. Okay, so now 4 minus 3x minus 3h divided by x plus h plus 2 is f of x plus h. Do we understand this? If you have questions, please stop me. Yes, please.
How do you go from like that first step when you do f of x plus h minus f of x divided by h?
So when I'm given a function, which is 4 minus 3x over x plus 2, I look at the function and I understand its pattern. So this function tells me that every time I apply it to something that the function is defined at, is there a value for which this function is not defined and I can never touch it? Of course, obviously. So f of blah equals 4 minus 3 times blah over blah plus 2. If blah is x plus h, then I have x plus h, and I have x plus h. This is what the function is telling us. So then f of x plus h will be 4 minus 3 parentheses x plus h divided by x plus h plus 2. So this is 4 minus 3x minus 3h over x plus h plus 2. Now, moving forward, is this clear forever? Is it? Okay, perfect. So then let's come back. Is this okay now, everyone? Yes. Yes, it's the same. It's right here. It's right here. Okay, it's the same thing. It's what we just wrote. Okay, minus 4 minus 3x divided by x plus 2 divided by h. So remember from last time when we evaluated and simplified the difference quotient, the answer cannot be 0. The answer cannot be 1. I saw answers of 1. I saw answers of 0. I saw answers of h plus 2. It's not possible. The least common denominator cannot go away. So you can never get here as the final answer 5 over h. That's not possible. Because this least common denominator that we are going to determine will not go away. Okay? So the least common denominator is
x plus h plus 2, x plus 2.
Very good. Is the product of those two. Now, we cannot just copy the numerators. That's not how we add and subtract fractions. So we need adjustments for the numerator of the fraction. This denominator was multiplied by this. We have to multiply the top by the same quantity. This denominator was multiplied by this. We have to multiply the top by the same quantity. Do we understand this step, this mechanism? Again, if you have any difficulties, stay with me after class so we can go over another problem. Okay? This is very important. Everything in this class is based on this concept of the difference quotient. Okay, so then I have to write here x plus 2, and here x plus h plus 2. Now I have to distribute. So I have to multiply x by these 4 terms. 4x minus 3x squared minus 3xh. Then I have to multiply 2 by these 3 terms, or distribute 2 to these 3 terms, plus 8 minus 6x minus 6h. All this you see here is only the product of x plus 2 times 4 minus 3x minus 3h. Now I have to multiply 4 minus 3x, distribute 4 minus 3x to x plus h plus 2, keeping in mind that there is a minus sign in front. All terms that I'm going to write next will have a change in sign. Why? Because of this symbol right here. Ready? Okay, so 4 times h with minus in front. 4 times x, I'm sorry, first. 4 times x with minus in front. 4 times h with minus in front. 4 times 2 with minus in front. You will learn very quickly that I always run out of room. Sorry about that. Negative 1 times negative 3x, and now this cancels the minuses. So 3x times plus 3x times x is plus 3x squared. 3x times h is plus 3xh. And 3x times 2 is plus 6x. Now I stop and I remember two things. Number one thing that has to happen from all these millions of terms that I have here, every term that does not have h in it must go away. If it doesn't, I made an error somewhere. So now let's try. I'm looking for 4x that must go away, and it does. I'm looking for negative 3x squared with positive 3x squared. It has to go away. Well, this is really nice. Negative 3xh with positive, they also go away. They don't have to, but it's a bonus. I'm happy they do. The positive 8 with the negative 8 must go away. The negative 6x with the positive 6x, they indeed go away. And now I look carefully and I only see 2 terms left. As I said again, 2 out of 23 got this correct answer. So negative 10h divided by x plus 2, x plus h plus 2 times 1 over h. If you disregarded the denominator, you cannot get the correct answer. The denominator doesn't go away. All you have to do now is the second step that has to happen, the second consideration, right? These two go away. It's a must. And the simplified form is indeed negative 10 divided by x plus 2, x plus h plus 2. I will make myself a note and say, and write in there, I studied nothing from Thursday till today. This will not happen again because I'm going to fail this class. And I'm going to waste my money and my time. So put that and circle it. And I'm hoping you understand that I do care. Otherwise, I will not say anything. I deeply care about all my students in my classes and all the students. But especially you, because we did this in class with several examples. Okay, moving forward. Yes?
So maybe it's to understand, like, there would be a, under the h on the last black equation, there would be a 1, and so you flip it so you can multiply the reciprocal.
Exactly, but that's how I divide. So h is the same with h over 1. So when we divide fractions, we copy the fraction from the top, and we multiply it by the multiplicative inverse of the denominator. Correct, yes. Okay, so this is the final answer. Now, between now and Thursday, I need to see that you either have a book or you are registered in WebAssign. If one or the other doesn't happen, then we have to sit down and talk about it seriously. So if your name is in WebAssign or you show me a book, then you're on the right track. Tiwa, please put that away. I think I said it 3 or 4 times already from the beginning of the semester. You have your backpack, please put it in your backpack, please. Thank you. Okay, now, is this clear? All steps? All steps? You have all the lectures in Canvas. I will redo each and every problem several times moving forward till I understand them and I can do this on my own. Okay? We don't want to stumble from the very beginning. And we also missed 1 class. So this week I need to sit down with each and every one of you just to make sure that you're on the right track, to make sure that you don't need this extra assistance from me. If you do, please ask for it. Okay? But I hope that this moving forward will not happen again. Is that okay, everyone? Yes, please.
Are you still doing the meeting for extra credit?
Yes. Yes. And I extended all the entire week because we didn't meet last Tuesday, of course. Okay, good. So any questions on this? Any questions? Okay, I have to move on. Do you have anything else for me from what we covered so far before we continue? and talk about 2.2, the limit of a function. Anything? Do you have anything for me? Okay, 2.2, the limit of a function. Do you remember what we said last week sometime ago? I think it was Thursday, when we said when Q gets closer and closer to P, then the slope of the secant line PQ will get closer and closer to the slope of the tangent at P. Well, this is not really the way we write this concept. Okay, so there is what is called the limit operator. Limit operator. Limit operator. Do we know other operators? Yes, we know natural log. Natural log is an operator. Okay, we know another operator. Yes, the square root. The square root is an operator. Okay, the limit operator is something like LIM of a function, let's say limit of f of x, when x approaches a. So one more time, let me put in writing how we read this. The limit of f of x when x approaches, oops, there is an agent here, approaches a from either side. And we'll talk about what it means in a second. So the limit of f of x when x approaches a from either side. And here's an example. We're going to graph a function. The simplest possible function. Can anyone tell us what function is this? Of course, the simplest possible function, linear. Okay. So let's say how will I write such a limit for this particular point? I will write the limit of function f of x, whatever function that is, as x approaches 2 from either side. And let's figure out what this is and what it means. So if we come from this side with smaller values than 2, we get closer and closer to 2 from this side. And at the same time from this side, from the right-hand side, as we get closer and closer to 2. And if we do that simultaneously, where will the function value go? Or function values go? Do you all see that? So then we say that the limit of this function, whatever function that is, as x approaches 2 from either side is 3. Note, a limit exists only if it is a number. A limit exists only if it is a number. If I say now for this particular function, here's a function. I'm going to graph. Here's the function. Here's f of x. And I will say that limit of f of x as x approaches 3 from either side. What do you think the answer would be? Yes. This is a way of saying it doesn't exist. How it does not exist? It's infinity. It's not a number. The limit does not exist if it is not a number. This is not a number. Infinity is not a number. It's just a symbol. Okay, next. Here's a third possibility. Not the last one. Again, at x equals 3. I'm graphing a function now. In this particular case, what will I say? The limit as x approaches 3 from either side, what will you say? Indeed, you cannot write infinity. You cannot write negative infinity, and you cannot write a number. So what we have to write in this case is D N E, and of course that stands for it does not exist. It does not exist. The limit does not exist. What about this one? The limit doesn't exist, but I cannot write DNE here. I must write infinity. It does not exist, but I can tell in which way it does not exist. It's infinity on both sides. Also, we have what we call left-hand side limits, left limits, and right limit. So for example, for the last problem, or the last function, I can write the limit of f of x as x approaches 3 and put a plus as the power, like a power, put a plus like a power. That means from which side? Yes, from the right, meaning with values that are larger than 3. For the previous function, for the previous graph, what will you say the answer would be? Infinity indeed. What will you write, and what will this represent with a minus as the power? There is no minus as the power, but this is the symbol we use. This will be negative infinity, correct? So as x approaches 3 from the left-hand side, look what the function's value do. They get closer and closer to negative infinity. Since the left and the right are not the same, and furthermore they're infinities, the limit does not exist. Here's another example for you. And we can go back to the piecewise defunction we graphed. I'm just going to graph something. So let's say this happens at 2. This is 3, and this is 5. And here's a function. Is this a function? Yes. By the vertical line test, it's a function. Any vertical line crosses the function in only one point. This is an open point. The function doesn't exist there, but the function exists here. So if I ask you for this function, how much is f of 2, what will you say? Excellent. So let's look at the limit of f of x as x approaches 2 from the left, and limit of f of x as x approaches 2 from the right. So this is a new graph, new function, and then we'll look at problems from the book in a minute. So the first one from the left. Any questions, please? Any questions? Stop me anytime. Stop me anytime. Okay. So as x gets closer and closer to 2 from the left-hand side with numbers smaller than 2, where will the function values go? Closer and closer to 5, right? I follow the function. It gets closer and closer to 5. We measure the function on the y-axis. We measured x on the x-axis. One more time. As x gets closer, this is what happens simultaneously. As x gets closer and closer to 2, function values get closer and closer to 5. Is that better? Okay. Simultaneously, as x gets closer and closer to 2 from the other side, the function values get closer and closer to 3. Okay, very good, awesome. So the left-hand side is 5, the right-hand side is 3. And now if I ask you from either side, simultaneously from either side, what will you say? Do you all agree with that? Yes, please.
I don't understand how it's 5 from the left and 3 on the right.
Okay. So, Sx, look, see my fingers? So, Sx is here, y is here. Sx is here, y is here. Sx is here, y is here. As x is here, y is here. Close to which number?
5. Then wouldn't it be the same for the other side?
Okay, let's do this again. From the other side. When x is here, y is here. 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 Better?
Yes.
Good. Other questions here? Yes, please.
So when you're asking us a question, like how to read the graph, would you like specify what you're looking for?
Yes.
Okay.
Of course. Of course. One type of very good question, Vanessa. So one type of question would be, here's a piecewise defined function, graph it, and answer questions. And the questions would be about the limit. Very good question, thank you. Okay, so let's look in the book now at several examples. Please choose anything you want from here so we can analyze and answer the questions about limits. So you choose. Any problem? Which one? You want to start with 8? You said 8?
Yeah.
Okay, perfect. I'm making sure. Okay, in 8, for the function r whose graph is shown, say the following. So here's the graph. What I see here is this. Right? That's the function, correct? Yes? Good. So now it says find the limit of r of x as x approaches 2 from either side. I look at 2. I see what happens to the left, from the left, and from the right. What will I say?
Negative infinity.
Do you all agree? Okay. So write it down so I don't have to move the book, move the book, write, and so on and so forth, and then you'll give them to me, and I'll put them all together for you in writing. Okay, B. 5 from the other side. 5 is here. 5 from the other side. Infinity. So part B is infinity. Do we all see that? Yes? Okay, part C. Limit of r of x as x approaches -3 from the left. -3 from the left. Do you all agree with negative infinity? Okay. -3 from the right. And if I want to add here from either side of -3, it does not exist. Nothing exists anyway. If I say infinity, the limit does not exist, but I cannot say DNE unless it's this situation. But if it's this situation, it's DNE, but I have to write infinity. This situation is DNE, but I have to write negative infinity. Okay, so now the equations of the vertical asymptotes. We know from pre-calculus what vertical asymptotes mean, where the function is undefined, rational function most of the time. The function is undefined, and the sides, the values of the function from either side will be one option, second option, third option, fourth option. At least one of these has to happen. At least one, not necessarily both. At least one. Okay, so can anyone identify the vertical asymptotes of this function? No, x equals -3. Very good. Okay. Let's also look at one more. I would like to look at this problem, which is 6. Oh, can you give me, so I can write down for everyone the answers for number, what was it? 8 on page 96. In part A, the answer is? Okay, in part B? Okay, in part C? And in part D? I thought we said DNE.
Oh,
Okay, and then for part E, x equals, what was it, -3, x equals 2, and x equals 5. Any questions on this? Yes, are we okay? These are the VAs, vertical asymptotes. Is that okay, everyone? Okay, perfect. So moving on. I'm on page 5. Okay, ready? Let's also look at number 6. Okay, I'm just going to show the graph. So in part A, we're asked to find the limit of this function as x approaches -3 from the left. -3 from the left. Let me zoom in a little bit. Did the graph go away? Okay. Notice that this is an open point, correct? Okay, remember when we brought point Q closer and closer to P? Here's was P and we brought Q closer and closer to P. What did we say? That Q will not overlap P. Q will never be equal to P, or it's the same with P, right? It will be very, very close, but not the same. Which means it doesn't matter whether the function is defined at a point, it can still have a limit. The function does not have to exist at a point where it has a limit. Okay? Because we cannot make, when we calculate the limit, when x approaches -3, we specifically mean x does not equal -3. So please keep in mind the function existing does not influence the limit. The function may exist and the limit exists. The function may not exist, but the limit exists. So for example, for x approaches -3 from the left, what would you say? This is 1, 2, 3, 4. Limit from the left? 4. Limit from the right? The function value at -3 does not exist. Is that clear? Okay, yes, please.
I didn't really understand the last part where you said the function doesn't really go with the limit.
No, I said the limit may exist even if the function is not defined at that point. So here there is an open point. The function does not exist there. It may exist somewhere else or not at all. So you may have a full point here or no full point at all. The limit still exists at that point. Because when we say, don't forget what you want to ask. As x approaches -3 from either side, we say x does not equal -3. So we don't care whether the function exists there or not.
So in that case, you're just trying to find the value that the graph is approaching?
Exactly. That's the only concept that we need here. Yes. Good. So please write it down for part A. The limit from the left of -3 is 4. The limit from the right for part B. The limit from the right is 4. The limit from either side? 4. Exactly. What about h of -3? Exactly, does not exist. So one more time. The limit from the left for part A is 4. The limit from the right is 4. The limit from either side is 4. The function value at -3, it does not exist. There is no point. There is no full point when x is -3 anywhere. Okay. Limit of h when x approaches 0 from the left. Do you all agree with 1? 0 from the left is 1. We all agree. Yes? Okay. Limit from the function as x approaches 0 from the right. Do you all agree with -1? Okay. From either side of 0. Does not exist. From the left is 1, from the right is -1. So g does not exist. H of 0, please. Indeed, where the full point is. H of 0 is 1. Awesome. Limit of h of x as x approaches 2 from the left. 2 from the left.
2.
Do you all agree with 2? Yes? I'm sorry, forgive me. It was 2 from either side. It doesn't matter. 2 from either side.
2.
2 indeed. Both sides go to 2, even if the function is not defined there. What about age of 2?
Does not exist.
Does not exist. What about the limit from the left? I'm sorry, it's from the right. This is from the right. From the right of age of x as x approaches 5. Limit from the right as x approaches 5. Yes, 3. Now we have to talk about the last one. Ready for the last one? This shows that the function is jumping. We say it's oscillating. So as x approaches 5 from the left, the limit does not exist. It's up here, it's down here, it's up here, it's down here, up here, down here, as x approaches 5 from the left. From the left-hand side, the limit is d and e. So the last one, L, d and e. It's an oscillating limit. Okay? So now if you give me the answers so I can put them in writing for everyone to have here. Yes, any questions? So this was 6 on the same page. Yes, part A.
4.
Part B. Part C. Part D. Part E.
1.
Perfect. Part F.
-1.
Very good. G. H.
1.
Is there anything else? Or are we done?
Yes.
Oh, yeah. No, we have, what else we have? Yes, I, J, K, and L. Good. I, J, K, and L is D and E. Okay. I, 2, J,
Does not exist.
and this was 3, right? Okay, very good. So now, oops. Sorry about that. Good. Any questions on limits? Here's an example from real life situation that I would like us to look at for a moment. So what type of function is this? Exactly. For this piece is this graph. For this piece is this graph. For this piece and so on and so forth. It's absolutely a piecewise defined function. Since we talked about piecewise defined function, I gave you probably 1 or 2 examples. Here's another. A patient receives a 150 milligram injection of a drug every 4 hours. So he comes to the hospital, he gets the injection. 4 hours later, he gets the injection. 4 hours later, gets another one, and so on and so forth. The graph shows the amount f of t of the drug in the bloodstream after t hours. Find the limit of f of t as t approaches 12 from the left. T approaches 12 from the left. It's 150. Okay. Limit of f of t as t approaches 12 from the right. So from the right is 300. What does this mean? So it's 300 when he gets the injection, and then 4 hours later, and at different levels, of course, 4 hours later, it's a totally different level. It decreases, yes.
From the right, why would it be the same number?
From the right, it's right here. As x approaches or t approaches 12 from the right, the function values get closer and closer, closer and closer to 300. So if I'm here, the function value is here. If I'm here, it's here. If I'm here, it's here. If I'm here, it's here. Okay, and explain the significance. So that's a perfect example for a piecewise defined function and limit. Okay, any questions? I would like us to look at an example of this kind, and then we can look at infinite limits. Some examples. So here this is a very typical recurrent type of problem in this class. So sketch the graph of an example. There is more than one correct answer, in other words. Sketch the graph of an example of a function that satisfies all the given conditions. You're going to have a problem like this too, so please choose one. Any problem you want. We want to do 15. Let's do an even number problem so I can assign an odd for you to look at. But it's up to you.
16.
Okay, let's do 16. So here is 16, and let's copy the information. So this time we are working on problem 16, and that is on page 97. Okay, we are given limit of f of x, xx approaches 0 from either side, let's say, is 1. Limit of f of x, as x approaches 3 from the left, they say is negative 2. Then limit of f of x as x approaches 3 from the right. And the last two, f of 0 is negative 1. And f of 3 is 1. Every time we look at problems of this kind, we will create a table. In which we will summarize the information we have. So at any point in time, before we graph the function, we will summarize the information in a table. So that it will be easy to identify what we are doing. It will be easy for us to come up with an example. And I'm still seeing cell phones under the table. And he knows who it is. Okay, so I see 0 here. I see 3. And nothing else when it comes to x. So this is 0 and this is 3. I am told that f of 0 is negative 1, so I'm going to write negative 1. You don't have to cross it out. I'm just making a point. I'm also told that f of 3 is 1, so I write it underneath. So this is done as well. Then I'm going to use two parentheses, left and right, exactly how we did it with piecewise defined functions. Just create two parentheses. And now I'm going to put the information I see, or I'm given the other three pieces. Okay. Limit as x approaches 0 from either side is 1. Fine. I'm writing inside the parenthesis, I'm writing 1. For 3, so this is done. For 3 from the left, what will I write? Awesome. So this is done, and it's in my chart now. And what will I write from the right of 3? 2. And this is in my chart. That's all I need. I summarized everything I was given in this table. And now here is my example of a function. You can come up with a totally different one, which is fine. Of course, I will start by plotting the points 0, negative 1, and 3, 1. 0, negative 1 is this point. 3, 1 is this point. Now, obviously, these limits left and right are the same. So the function left and right must go to 1. This is my example. You don't have to copy it. You can create your own. So I'm done with the point 0. The limit from the left is 1. The limit from the right is 1. The function value is negative 1. Yes, Vanessa?
I was just going to make it like an open circle, or does that not matter?
It's not a function if I put it full. It's already a point here. If this is a full point, then it's not a function anymore. By the vertical line test, it hits the vertical line at 0 hits the graph in 2 points. And that is not going to be a function anymore. Better? Perfect. Very good question. Okay, so now let's see the limit from the left. The limit from the left is negative 2. So I'm going to continue my function here. And the limit from the right is positive 2. This is my example. Yes, you can come up with another, with many other examples. Again, I'm checking all the conditions. If the function I created fulfills with all of them. Limit from the left is 1. The function value is -1. Limit from the right is 1. The function value is 1. The limit from the left is -2. The limit from the right is 2. So this is my example. And there is more than one correct answer here, of course. Any questions on this? Yes, please.
Can you go over how you got the points again?
F of 0 is -1, 0, -1. F of 3 is 1, 3, 1. And then I put in these limits. I was told that the limit of f of x as x approaches 0 from either side is 1. And I was told that the limit from the left is -2. And the limit from the right is 2 on the left and right of 3. That's why I crossed them out, so I know I already have every... Oh, yes, please. Tiwa? This one and this one and this one? This is a function. So if I make the mistake to fill this in by the vertical line test, it will not be a function anymore. Say it again? But I'm told f of 0 is -1. It's carved in stone. I can't change that. So that must be the full point and no other at 0. I'm told to become a 1, carved in stone. I can't change that. So on this vertical, there is no other point but this one. In other words, when x is 3, there is only one full point. If I, by mistake, I put another, I do not create a function. I create a relation, but I'm asked to find a function. Present an example of a function. Is that better? Other questions? Very good questions. Anything else? Okay, so moving on now then to the last part of this section, which deals with infinite limits. Before we do that, infinite limits. I would like to look at and refresh your memory on a couple of functions that are extremely important. So here's a function that we already discussed. Anyone remembers what this function is called? And this is, again, thank you. Was it Savannah or Emily? Who was it? Both. Okay. You're reading my mind. Good. Indeed. This is tangent. So tangent x. So then limit as x approaches pi over 2 from the left of tangent x, and limit as x approaches pi over 2 from the right. Oops. I meant to write tangent x. Can anyone other than Emily and Savannah give us the answer for limit of this function tangent as x approaches pi over 2 from the left?
Positive infinity.
Do you all agree with positive infinity? So as x gets closer and closer to pi over 2, obviously the function values we say blow up. Very good. Awesome. Thank you. What about the second one? Do we all agree with negative infinity? As x approaches pi over 2, a negative pi over 2 from the right, the function values get closer and closer to negative infinity. Do we agree with that? Very good. Okay. Here is another function, which is f of x, extremely important function. Can anyone tell us what function this is? Dylan, are you okay? Okay. What type of function is this?
Rational.
Very good. So here's the graph of this simplest possible rational function. There is no other simpler rational function but this than this. Okay, here's the graph. It does not touch the x-axis. Sorry if you see it too close. So this is the function 1 over x. Now I have two questions here. Limit of 1 over x as x approaches 0 from the right, and limit of 1 over x as x approaches 0 from the left. What will you say about the first one? Do you all agree with positive infinity? And moving forward, this is for your notebook. We have to remember this, that this answer is positive infinity and this answer is negative infinity. And now, of course, I'm going to ask you, what is the limit of 1 over x as x approaches 0 from either side?
Does not exist.
Well done. Thank you very much. Does not exist. Okay, two things here before we choose problems from your book. We have 7 indeterminate cases. I'm going to put in parentheses later. For now, I just want you to remember that there are 7 different indeterminate cases. I'm not talking about undefined situations. I'm talking about indeterminate cases that no one can predict. So I'm going to just give you 2 examples, and then we'll add to this list. So 1 will be 0 over 0. Here's another example, infinity over infinity. And there are 5 more. So 3 through 5 later. You know what I mean. My 5 is 7 and my 7 is 5. Sorry about that. So from 3 to 7 later. When we encounter them, I'll refresh our memory and we'll go back and discuss them again. Okay, so this is an indeterminate case. It's not called undefined, but indeterminate, like this one. Why am I discussing this? Well, so 0 divided by 0 is an indeterminate case. Any number not 0 divided by 0, this is an undefined situation. Now, from these two, when I calculate a limit, this one may exist. How come? Well, 0 over 0 may be, at the end of the day, 5 or 15. This one will never exist. I can never transform or get, if it's an undefined situation, I could never get a number out of it, ever. So I'm going to call this one, there is hope for the limit to exist. This one, no hope whatsoever. Okay? For this, there is hope that the limit exists. That's what I mean. Here, no hope. The limit will never exist in this situation. Here, there is chance. There is hope that it exists. Here, never. Okay. For example, we already had an example right here. See? 1 divided by 0. As x approaches 0 from either side, 1 divided by 0 will never exist. It's infinity. Same thing here, negative infinity or DNE. So these situations, a number over 0, the ones with no hope, have 3 possibilities. What are those possibilities? So we can write them again. And DNE. So these are the 3 possibilities. This one, your guess is as good as mine. I don't know. Does it have to exist? No. I'm only saying there is hope. It may exist. I'm not saying it exists. I'm only saying it could. So I think with this information, let's work on problem 30 on page 98. Any questions so far? Okay. 30 on 98 is limit. As x approaches -3 from the left, of x plus 2 divided by x plus 3.